Okay, so 213 part B or part 2, however you want to state it, we are now getting into the inequalities of logs. Okay, but we're also going to be still dealing with inverses, which we've been dealing with the whole unit. It's not anything different. All right. So, and again, we already know the rules as far as inverses. You swap the x and the y, and then you basically solve for y using whatever inverse inverse operations that you need to do. Okay, the big thing dealing with logs and exponents, again, is that you have to get it down to those three pieces so that you convert it the other way. Okay, so that has not changed. The difference is that you're rewriting a function rather than trying to solve an equation by, getting rid of pieces and then changing it over. Okay, so we already know what the basic form of an exponential function looks like. It's got your a, right, which is your dilate and your reflect. B is your base. It's got your horizontal and your vertical translations. Same thing with a log. A does the same thing. It reflects, it dilates, log base B. And then you have your H that's in the parentheses and your K that's outside. Okay. So we're going to find the inverse of this exponential function. And again, by basically, rewriting it as a log, right? Because obviously a log would be the inverse of an exponent, and that means we have to get it down to the correct form first. So y equals 3 times 2 to the x plus 4 minus 15. Swap x and y. Okay, so I have to get rid of two things in order to be able to rewrite this as a log. Okay, but instead of actually something that's going to simplify, it's just going to become another function. So same rules apply as far as inverse PEMDAS or reverse PEMDAS. I'm going to add 15 first. So I have x plus 15 equals 3 times 2 raised to the y plus 4. I could divide by 3, or I could rewrite this as 1/3 times x plus 15. Either one works. I like looking at it as far as the actual pieces. So I'm going to go ahead and multiply it by 1/3. And again, I can distribute that if I want. So multiply by 1/3, multiply by 1/3. That's going to give me 1/3 x plus 5. And by the way, that is all one piece, equals 2 to the y plus 4. Again, this is all one piece. This is actually the answer on the outside of the exponent. It's all together. It'd be the same thing as if you wrote it as x plus 15 over 3 as one big fraction. It's one piece. So we've now got it down to the three pieces that we need. So this is going to be log base 2 of, it's now my argument, 1/3 x plus 5 equals y plus 4. And then I need to subtract 4. And since my argument is all nicely in parentheses, I know this goes on the outside. So this is log base 2 of 1/3 x plus 5 minus 4. And that is going to be my inverse function. And we wrote it as f of x, which means we now need to rewrite it as f negative 1 of x to show that that is the inverse. So it's the same thing that we've been doing for a while. We're just doing inverse operations. It's just the order that you do them in is very specific and very required. All right, so let's try one that's in log form, and we're going to rewrite it as an exponent because that would be its inverse operation or its inverse function. So y equals negative 3 log base 5 x minus 4 plus 6. Okay, so swap x and y. Log base 5 of y minus 4 plus 6. Same deal. You are going to need to get rid of the 6 and the negative 3. How you do it is, again, how you write it is your choice. Minus 6, minus 6. But remember that however you write it, that's going to be like the whole thing that your exponent's going to have. So make sure you keep that in mind. X minus 6 equals negative 3 log base 5 of y minus 4. Okay, so now I need to divide by negative 3. Again, a couple of choices. I can also multiply by negative 1/3 and distribute. So if I distribute the negative 1/3, I'm going to get negative 1/3 x plus 2. right, equals log base 5 of y minus 4. So now I'm going to be raising this whole thing as the exponent of my base of 5. So 5 raised to the negative 1/3 x plus 2 equals y minus 4. And then that in effect becomes my vertical translation. Negative 1/3 x plus 2 plus 4 equals basically now my g inverse of x. Okay, if you can start seeing, there is kind of a pattern that happens. Your horizontal and vertical translations switch places, basically. Right, whatever was your horizontal is now going to be your vertical. Change the sign. Whatever was your vertical is now going to be part of the horizontal, and it was, negative 6 divided by 1/3, or multiplied rather by negative 1/3. And your A is now going to be your A inside the exponent. It's sort of like they swap positions. Okay, so not too bad as far as that goes, and we could, throw some stuff in there like find g negative 1 of 4, and you would know that that was an output from your, original function, like all kinds of things that they can ask you to do with these inverses. And this is exactly what they're asking on this one. They're telling you that this is h of x and that k of x is its inverse. You don't even have to know, how to write it. They're just telling you it's the inverse. They want to know, so basically, I'll put it this way, they want to know where the inverse of the original function equals to 1. So that's an output that they're looking for. And if you're looking for an output on the inverse, that means you're looking for an input on the original. So all you have to do in this case is literally substitute 1 in. So 3 squared minus 2, that's 9 minus 2. The answer is 7. Right, and writing it correctly the way you're supposed to, k of 7 equals 1, since you're looking for the x values that actually get that. And again, that's just recognizing that they're talking about the output of an inverse, which means it's the input of the original. Okay, onward to actually dealing with inequalities. That means we're going back to having to do number lines again. Now remember, we already found out on logs that they have extraneous solutions. So that means you're going to have to put those on the number line as well as any solutions you find. All right, so let's take a look. Doing them the same way we did before. Okay, so, all right, let's go ahead and take a look at the first one. This one cannot be factored, right, as far as right now, as far as looking at extraneous solutions. So I can look at this one and know that my extraneous solution right now is that x must be bigger than negative 3, okay? So again, the other one's not factorable, so we'll just stick with this one. X has to be greater than negative 3. And that's going to have to go on our number line when we find our other two possible solutions. So they want to know where this is greater than 0. All right, this is a subtraction, which means I'm dividing my pieces. So x squared minus 4x plus 7 over x plus 3 must be greater than 0. Okay, so that means I need to basically, sorry, my cat is being weird. So basically that means that I need to go ahead and solve this. Again, the top is not factorable as is. So what we're going to do, there's a little trick that we are going to set. Okay, so just bear with me. If it has to be greater than or equal to 0, that means it has to be 1 or more, right? So we're going to go ahead and just call this 1. We're going to rewrite this. So x squared minus 4x plus 7 over x plus 3 greater than 1. So now I can actually cross multiply and get something that's possibly factorable, okay? So cross multiply x squared minus 4x plus 7 greater than x plus 3. And then we're going to move everything to the left so we can actually go ahead and factor. All right, so x squared minus 5x plus 4 greater than 0. Now, this is actually factorable. What multiplies to give you 4 and adds to give you negative 5 would be negative 4 and negative 1. All right, so negative 4, negative 1. And that means when I set them equal to 0 and solve, my numbers that I'm going to be checking on my number line are going to be 4 and 1. Also the negative 3 that was the extraneous. Okay, so go way back to what we were doing with rationals and polynomials. We're checking negative 3, right? That's an extraneous. And then we're just checking two possible solutions of 1 and 4. So those are two possible x solutions. So we need to pick numbers that are on either side and in between, just like we did before. And again, we're just going to substitute it in to see where it's going to be positive. All right, so I'm going to check negative 4, 0 because it's between negative 3 and 1, 2 and 5. All right, so let's try and figure out where this is going to be. So if I substitute in negative 4, and by the way, you would substitute it into this form, right, after you've simplified the logs together. So negative 4 squared is 16 plus 16. That's going to be a positive over a negative. So that's a negative. All right. And then substituting in 0 into this one should mean that all I have left is 7 over 3. That's positive. All right, substituting 2, I'm going to get 2 squared is 4, minus 8 is negative 4, plus 7 is, wait, brain fart. All right, brain fart. Okay, so between 1 and 4, let's try that again. So 2 squared is 2, minus 2 squared is 4. Wow. 4 minus 8 is negative 4, plus 7 is 3 over 5, so that's going to be positive. Don't worry about me. And then 5 squared is 25 minus 20, so that's positive over positive. That's also positive. These don't have the same patterns that polynomials and rationals do. As far as being minus, plus, you're really going to have to check them all to see where it works. And so far what it's showing is that my answers must be greater than negative 3 as far as my choices. Did I do something wrong? Let's check. Because this thing is telling me that it should be negative between 1 and 4. So let's see. 4. No, I'm getting a positive answer. 4 minus 8 is negative 4. Plus 7 is 3 over 5. That's still a positive answer. Okay, I think this thing is being loopy. So my answers at this point are everything greater than negative 3. Okay, so x greater than negative 3 is not only the extraneous, but it's also the answer. I'm going to graph this later just to be sure, because like I said, it's telling me that it should be negative between 1 and 4. And that's not what I'm tracking. So very, very weird. Okay, so anyway, for right now, we're just going to say x has to be bigger than negative 3 for it to be basically above the x-axis because they want it to be positive. All right, so let's try the next one. I don't know why that is showing me that. Okay, so unless I made a mistake, and if I did, hey, call me on it in class tomorrow and let me know I screwed up when I substituted stuff in. It's fine. Okay, so checking for extraneous, x has to be greater than negative 4. That's definitely something that I will check. In this case, they just want to know where g is bigger, or g is less than x. G is less than h, sorry. So this one's actually not as bad. That means that the natural log of x squared plus x minus 5 is less than the natural log of x plus 4. And we treat this like an equation. Right, just, okay, say that one has to be less than the other, and that means everything gets moved to one side. So x squared, that's gone, minus 9 has to be less than 0. That's an easy one to factor because it is a perfect square, so I know it's going to be plus 3 minus 3. And then that means on my number line, I'm going to be checking negative 4, negative 3, and positive 3. Okay, so again, numbers in between and around, -5, -3.5, 0, and 4. So we're going to plug those in and see what works. Okay, so again, I'm going to check my original function, x squared minus 9. So if I substitute in -5, that's 25 minus 9, that's going to be positive. If I substitute in -3.5, 3.5 squared minus still going to be, oh wait, yeah, I want it to be less than 0, never mind. Okay, so 3.5 squared is still going to be bigger, so that's still going to be positive. If I substitute in 0, that's going to be negative, and if I substitute in 4, that's going to be positive. So the only answers that I have are between -3 and 3. All right, one more. Okay, so less than or equal to 31. This actually makes this a much easier equation because basically what you have is 1 minus 4 times 2 to the x minus 3 has to be less than or equal to -31. And since it's an exponential function, we don't have to worry about extraneous. Again, I can't change it until I move stuff over. So -1 minus 1. 4 times 2 to the x minus 3, less than or equal to -32. Now, if you remember your specific rules from exponents, if I divide by, or from inequalities rather, if I divide by a negative, I have to flip my inequality around. So what I get is 2 to the x minus 3 has to now be greater than or equal to 8. I'm back down to basically a normal exponential equation. I can force the bases to match. So greater than or equal to 2 to the third. So that means x minus 3 has to be greater than or equal to 3. X has to be greater than or equal to 6. Those are much more straightforward, obviously, than the logs because we don't have to worry about doing a number line to actually check them. So if we have any questions, we will go over more of this tomorrow. Just let me know.